So here in section 6.7, we want to look at the hyperbolic functions, and these behave similar to the trig functions, except they're defined here in terms of exponentials instead of the unit circle. So hyperbolic sine, or sinh of x, is defined to be e to the x minus e to the negative x divided by 2. Hyperbolic cosine, or cosh x, e to the x plus e to the negative x divided by 2. And hyperbolic tangent is sinh divided by cosh, just like regular tangent, trig function is sine divided by cosine. So here's the graphs down here. For hyperbolic sinh, that's this one here. This is the graph of 1/2 e to the x. And then this one down here is the graph of negative 1/2 e to the negative x, which are these two pieces here. I just brought the division by 2 out as a multiplication by 1/2. So for example, at 0, this is the y value for 1/2 e to the x, and then you got a corresponding negative y value for minus 1/2 e to the negative x, and you add those two and they cancel out. Your y value of 0, which is the bold black line, is the y value on sinh. So this is your sinh graph here. And you can just think of adding the two graphs vertically to get the y values on that bold line. So for example, again, here at negative 1/2, we've got a positive y value there, got a negative y value there. So if you go down by this far and then back up by that amount, you end up on the bold black line. Similar for cosh, here we have the graph of 1/2 e to the x, and here is 1/2 e to the negative x, and you add those two graphs vertically. So for example, at 0.5, here's the y value on 1/2 e to the x, here's the y value on 1/2 e to the negative x. If you take this y value, add it on the end, you end up on the bold black line, which is your cosh x. So it's a vertical addition of the graph for each point. And then if you divide the y values, you get the y values for hyperbolic tangent. Hyperbolic tangent here has some horizontal asymptotes at y equal 1, and then also y equal negative 1. Now the hyperbolic trig functions, they have identities just like the trig functions have identities. So first identity, cosh of negative x is cosh of x. So with trig functions, cosine negative x is cosine of x. Sinh of negative x is negative sinh x. That's true for trig functions also. Sine of negative x is negative sine x. But instead of cosine squared plus sine squared is 1, we get cosh squared minus sinh squared is equal to 1. And we actually want to try and prove that identity. So let's start out with our left-hand side here, cosh squared x, and then minus sinh squared x. And then I'm just going to bring down the definitions from up above. So cosh was e to the x plus e to the negative x divided by 2. I'm going to write that instead of division by 2, I'm going to write it as multiplication by 1/2. Okay, that whole thing gets squared. Minus, and then sinh was 1/2 e to the x minus e to the negative x. So there's your sinh. That whole thing gets squared. So to square this product here, we square the 1/2, which is going to give us a 1/4. And then we square this, so it's going to be e to the x plus e to the negative x multiplied by itself twice. So another e to the x plus e to the negative x. And then minus, and same thing but with negative signs. So 1/2 squared is actually going to be 1/4 out in front. And then we've got e to the x minus e to the negative x, and multiplied by itself. And now we want to FOIL these out. So we multiply e to the x times e to the x. The base is the same, so you're going to add exponents. So that's e to the 2x. Outer terms here, e to the x times e to the negative x. You're going to add exponents. X minus x is 0. E to the 0 is 1, so plus 1. Inner terms, same thing. E to the 0, which is 1. And then your last terms, negative x and negative x is negative 2x. So e to the negative 2x. And then minus 1/4. And we're going to get the same thing here, except it's going to be minus 1, minus 1. Your outer terms are plus minus, inner terms minus plus. But your first terms are plus plus, and your last terms are minus minus, which makes a positive. So this will be e to the 2x minus 1 plus e to the negative 2x. And then we can take this 1/4, it's common, and we can factor that out in front. And what we have left here then is e to the 2x plus 2 plus e to the negative 2x. And then minus the 1/4 we factored out, e to the 2x minus 2 plus e to the negative 2x. And now to subtract here, we'll change the signs and add. So minus, plus, minus, and we add. So e to the 2x and e to the negative e to the 2x cancel out. E to the negative 2x minus e to the negative 2x cancel out. So we just got 2 plus 2, 4. So this is 1/4 times 4, which is 1. And that's what we wanted right there.